Hey guys, Dr. Brown here, and there's some local students that have started in ninth grade geometry, and they had expressed some needs for getting their geometry skills up to speed. So we'll give it a shot as to starting a series on geometry for the ninth grade. Now, you'll notice we've drawn a few symbols up here, but I want to go through a few rules. You know me, I'm the rules guy. Okay, so you'll notice we have two parallel lines, and we have a traversing line coming through that. And on each side of this, we have various angles noted as angle A, B, C, and D, and down here, E, F, G, H. Okay. So some definitions: an acute angle, this one here, you'll notice that it's less than 90 degrees. And a 90-degree angle would look like that. Actually, a right angle, if this were A, B, C, the angle formed by ABC, if the two lines AB and BC are perpendicular, so we would say AB, that segment, if it's perpendicular, that's the sign for that. If it's perpendicular to BC, then those form a right angle. Okay, and that means that angle is 90 degrees. So a right angle is 90 degrees, and it's formed when two segments or two lines are perpendicular to each other. Okay, but if it's less than 90 degrees, it's an acute angle. Now, if it's an obtuse angle, you'll notice angle C is larger. If this were 90 degrees, it would be this, but it's larger, so that's an obtuse angle. So the measure of angle C is greater than 90 degrees, whereas, and it's obtuse angle, whereas the measure of angle A is less than 90 degrees, it's an acute angle. Okay, if two angles, let's go through some rules, and there's many for geometry, okay? But let's get a good idea graphically what they mean. If two angles form a linear pair, which basically is saying if I have this angle and that angle and it forms a line, okay, forms a linear pair, then those angles are supplementary. Now, what that means is the measure of angle A plus the measure of angle B equals what? 180 degrees. If I have a line and I have a point on it, and I said, well, I'm going to measure the angle, this angle. That's 360 degrees. A circle has 360 degrees in it. Well, half of that is what? 180 degrees. So in this first rule, if two angles forms a linear pair, they are supplementary. If they're supplementary, the measure of one of those angles plus the other one equals 180 degrees. Okay. For number 2, let's imagine line 2 is not there. Okay. And this forms somewhat of an X. Okay, so A and D would be considered vertical angles. And the measure of vertical angles are congruent, or they're equal. Okay, that's the vertical angle theorem. This one, number 1, was a supplementary postulate. Okay, let's go to number 3. If line 1 is parallel, that's what that symbol means, to line 2, if those two lines that are parallel is cut by a transversal, we're calling it T, then the corresponding angles are congruent. What's a corresponding angle? B and F would be corresponding angles. They're on the same side of the transversal, And you can see this one's above that line, this one's above the line, and they're both on the same side. Okay? What would be another one? A and E would be corresponding angles. D and H are corresponding angles. C and G, and you'll notice they're the same. And that's what this means. Since the lines are parallel and they're cut by transversal, then the corresponding angles are congruent. Parallel, corresponding, angles congruent. That's what their nomenclature in this textbooks means. Okay, if line 1 and line 2 are cut with a transversal, then the alternate interior angles are congruent. The alternate interior angles are congruent. Okay, I have a transversal, the alternate internal. So in between the two lines, there's an angle on one side of the transversal, and alternately, there's one on the other side. That's what they mean by alternate internal angles. If these lines are parallel, cut by transversal, alternate internal angles are the same. So angle D and angle C measure the same. So does angle C and angle F. They're the same. They're congruent. So this is the parallel alternate internal angle congruent. Okay, if line 1 is parallel to line 2 cut with a transversal, then the alternate external angles are congruent. Okay, parallel lines cut with the transversal, and the alternate external are congruent. So angle A, the measure of angle A equals the measure of angle H. The measure of angle B equals the measure of angle G. They're external of the parallel lines, and they're alternate. Okay, so that's the parallel, alternate, external, congruent. Okay, if line 1, line 2 are parallel, they're cut by transversal, then the same side interior angles are supplementary. Now we said supplementary meant earlier, if I have angles that add together to give me 180 degrees, okay, so what does that mean here? Okay, lines, parallel lines, transversal that cuts them, the same side interior, same side of my transversal, it means the measure of angle C plus the measure of angle E equals 180 degrees. That's pretty awesome. The measure of angle D plus the measure of angle F equals 180 degrees. That's the parallel, same size, internal angle is supplementary. Now there's complementary angles. If I have, back to this diagram, angle 1 and 2, you notice angles that are acute, they're less than 90 degrees, so both of these would be acute angles. And then the angle 1 plus the measure of angle 1 plus the measure of angle 2, they equal 90 degrees. If I have the parallel lines cut by transversal, and I don't have one of those up here, so just look at that diagram. So I have a transversal that cuts down through here. I've got an angle that's less than 90, another that's less than 90. They're all in that first quadrant. And that's, so measure angle 1 plus measure of angle 2 equals 90 degrees. It'd be the same if it were down here. Adding those two together would give me 90, or here, or up here. Okay? Now what do we do with all of that? That becomes when I worked in engineering all those years, doing something is why you're learning the math, okay, to actually apply it. Okay, what if angle B is 120 degrees? What can we tell about the rest of the angles there? Now, in some of your textbooks, they may say they have something like this, saying one little notch here saying these two lines are parallel. Maybe if they have more lines, they may have two of these or three of them, but you can count the number of these symbols. Sometimes you'll see like that, or maybe there's two other lines like this, and maybe those only have one tick on them and these have two. It says these two are parallel, these two are parallel. So just note that depending on the text that you're looking at. Okay, we know angle A and B form a linear pair. So what does that tell me? It says the measure of A plus the measure of angle A plus the measure of angle B equals 180 degrees. Well, angle B was 120. So the measure of angle A plus 120 degrees equals 180 degrees. So if I subtract 120 from both sides, I subtract it from this side, that goes away. So the measure of angle A is 180 minus 120, and that equals 60 degrees. Okay, so that means this guy is 60 degrees. What do I know about this one? Well, look at F. F is a corresponding angle to B. Well, F is 120 degrees. Okay, what does that mean to E? It's a corresponding angle to A. It's 60 degrees. Now this one, I have parallel lines. I have a transversal, which means the alternate internal angles are alternate internal angles are congruent, which means that one is 60 degrees. It also means the alternate external angles are congruent. This one's 60, that one's 60. This one and G are alternates, alternate external. What's left? This guy here. Let's use a different rule. Okay. We know it's going to be 120, but we want to say the alternate same side. Let's use this rule. I've got parallel lines. I have a transversal that's coming through. The same side internal angles are supplementary. It's saying that the measure of angle C plus the measure of angle E, they're supplementary, which means they equal 180 degrees. Okay, E was 60 degrees. So 80, we've subtract 60 from both sides, that goes away. So the measure of angle C is 180 minus 60, which is 120 degrees. Which, there is another rule I didn't write down, but if I were just cover up this, I have a line with a transversal. Well, we did talk about it. The opposite angles are the same. So this was, so I'll cover that up for a moment. Remember, this was the measure of vertical lines. So they form an X. So this one and this one are the same, but also this one and that one are the same. So C, but we could solve it a different way. It was 120 degrees. So that is one of the values of learning the different rules. Okay, let's see if we can work a more complex problem. I know you're excited about that. So I'm going to take all of these out, and we're going to make it a little bit more exciting. Okay. Now, I've written this over in the corner. One thing I need to do, I need to add a vertical line with my big giant. So I'm going to add a vertical line here. Now you may have to imagine, if you will, that this is a right angle, which what we learned earlier, line 2 is perpendicular to, we'll call this L. We don't call it L3. So we have L1 parallel to L2. Those are perpendicular to L3, which means this angle is 90 degrees, right? Because it's perpendicular to those other lines. This would be 90 degrees. All right, so we have this angle is 3x minus 11 degrees. And this angle is 4z plus 2 degrees. This angle right here. And this one is that angle right there. Okay? And down here, angle E is x plus 19. I think that's a 19. What else did we have here? Oh, and then they wanted to know this, what angle C is. Well, we already know C equals 90 degrees, but just by looking at it, because this line is perpendicular to L1, it's perpendicular to L2, so angle C is 90 degrees. What else do we know by using our rules? This is an acute angle. This is an acute angle. So I have 3x minus 11 plus 4z plus 2, that equals 90 degrees because they're complementary angles. What else do I know? I have two parallel lines cut by a transversal, so my alternate interior angles are equal. So it's telling me that 3x minus 11 equals x plus 19. Okay, so 3x, so I have two equations, one unknown. Let's solve for x, and then we'll go back over here. 3x minus 11 plus 11 equals x plus 19 plus 11. I've added 11 to both sides. It cancels it here. Now I'm going to, 3x equals x plus 19 plus 11 is 30. So now I'm going to subtract x from both sides. X minus x cancels, so 3x minus x is 2x. 2x equals 30. Now divide both sides by 2. 2 over 2 is 1. 1 times x is x. X equals 15. Now, what should I do here? I need to get z equals something that's a function of x, so I can just plug the x in. So minus 11 plus 2 is minus 9. So I have 3x plus 4z minus 9 equals 90. Well, if I add 9 to both sides, the minus 9 plus 9 cancel. 3x plus 4z equals 99. Now if I subtract 3x from both sides, so 4z equals 99 minus 3x. 4z, where did I see 4z? I have a 4z here. So 99 minus 3 times 15. So 99 minus 45. What is that? 54. 4z equals 54. So here I have 54 plus 2 equals 56 degrees. So this angle here is 56 degrees. Now, since we know that, we could just say 90 minus 56. That's no fun. Let's go with 3x minus 11. 3 times 15 is 45 minus 11. 45 minus 11, what is that, 34? So this one's 34 degrees. Now, we know from the parallel lines, transversal, the alternate internal angles are congruent. It's saying this angle and that angle are the same. So this x plus 19 should be 34 degrees. What was x? X was 15. So 15 plus 19. So x plus 19. So 15 plus 19, 34. Wow, how about that? So we know that's correct, and this is 34 degrees also. That is just a simple example of what you can do by knowing the rules. If this were a card game and we said, let's play cards, the first thing someone would say would be, hey, how do I play? What's the rules? Math is the same. Learn the rules, okay? All right, hopefully this helps. We'll have more coming. John, this one's for you and your daughter. And my contact information is at Metrotown Gongcha. So look me up, send me a note, text me, and then we can get on the correct pages where we can help you guys personally. So that's all for now. Talk to you next time. Thanks.